Hey guys, welcome back. In this video, I'll be showing you guys how you can create a wireless programmer shield using a Bluetooth module which can be used to upload your codes to your Arduino board wirelessly without using any USB cable. As always, I'll be giving you guys complete instructions including the circuit diagram, the PCB files if you want to make a PCB, and complete codes to make one yourself. My name is Jithin and I'm super excited to teach you guys everything you need to know about robotics, home automation and other fun DIY projects using Arduino and Raspberry Pi. If you are a true fan of all these things, make sure you check out our channel. You're gonna love it there. So, if you don't want to miss our future videos, make sure you subscribe to our channel by hitting the subscribe button right here. So let's get started. You guys might be wondering, why do we need a wireless programmer? Well, before answering that, let me ask you another question. What will you do if you need to change a code running in an Arduino board that is currently being used in a project? We will disconnect the board from the breadboard or the PCB, connect it to your PC, upload the new code, detach from the PC and put it back in the PCB or the breadboard, right? Using this uploader, you won't have to disconnect your Arduino board from the circuit or the PCB. In fact, you won't even have to use a USB cable to upload the new code. You can upload the code whenever you want using a laptop or a desktop computer. This method of wirelessly uploading the code to your Arduino board is called OTA or over-the-air code upload. To set this up, all you need is an Arduino board and a Bluetooth module. It will work on almost all Atmega boards, and for this project I will be using this HC05 Bluetooth module. This is one of the most commonly used and cheap Bluetooth module available in the market. You can easily buy this from Amazon or eBay. We will be doing this project in two steps. In the first step, we will be configuring this Bluetooth module. In the second step, we will be using this Bluetooth module to upload the code wirelessly to our Arduino board. There is a slight change between the circuits in step 1 and step 2. If you are using this PCB, you should be able to change the circuit by simply changing the position of these jumpers. But if you are using a breadboard, you should be able to change that using jumper wires. I have designed a circuit that will allow us to connect the Arduino and the Bluetooth module and do the configuration and wireless code upload without disconnecting the board. I used Altium Designer to draw the circuit and design the PCB. It is a powerful tool which can be used to design and create your own PCBs for your projects as well as complex and multi-layer PCBs for industrial use. I will provide the link to the trial version in the description. Make sure you check it out. This PCB will actually act as a shield to our Arduino Nano. On top of the shield, we can connect the Bluetooth module and the Arduino. There are headers for almost all digital and analog pins so that you can use this board as such for your projects. To change it from configuration mode to wireless programming mode, all you have to do is change the jumper position. You can easily power this board using a battery, a power adapter or a USB data cable and a power bank, which is what I prefer. Once the circuit was finished, I designed a compact PCB using Altium where I can fix all the components neatly. Here, you can see routing is on both sides of the board, that means it is a dual layer PCB. Now all you have to do is export the Gerber file. I ordered the PCB from PCBWay. PCBWay is a PCB manufacturer specializing in PCB prototyping, low volume production and neat and tidy PCB assembly. To order your PCB from PCBWay, go to PCBWay website and fill in the basic board details in the instant order form. From there, you will be redirected to a form where you can provide more elaborate board details. Update your board information in the PCB specification screen. In the next screen, you should be able to upload your Gerber file and submit it for a free review. Once the review is completed, all that is left to do is add to cart, make the payment and wait for your PCBs to arrive. Once you get all the components and the PCB, it's time for you to solder them together. Solder all the components onto the board and make sure to check the polarity of the components before soldering. After soldering, the PCB looks like this. The idea here is to make the HC05 module upload the code to the Arduino when the code is sent to HC05 module from our laptop. For that, we have to make sure that the baud rate is same for both the Arduino board and the Bluetooth module. The baud rate at which the program is uploaded is different for different boards. For Arduino Nano with Atmega 328, the baud rate is 57,600 and for the one with Atmega 168, it is 19,200. Now, to configure the Bluetooth module, we send 80 commands to it. There are multiple ways to do that. For now, I'll be using an Arduino board to configure the Bluetooth module. To do that, we have to set up a small circuit and program the Arduino to send the commands we provide in the serial monitor directly to the Bluetooth module. And this is that circuit. It's pretty simple, right? The ground of HC05 is connected to ground pin of Arduino, 5V of HC05 is connected to 5V of Arduino, the TX pin of HC05 is connected to digital pin 10 of Arduino and RX pin of HC05 is connected to digital pin 11 of Arduino. That's it. If you are using this shield, simply connect the jumpers to RX set and TX set and you are good to go. Now, you can connect your Arduino board to your computer using a USB cable. Before connecting Bluetooth module to the Arduino or the shield, press this button and then connect to the PCB or the breadboard. Hold the key until the Bluetooth module LED starts blinking at an interval of 2 seconds. Now, the Bluetooth module has entered the command mode. Once it is done, we can upload this code, and once the code is uploaded, we can open the serial monitor and start sending 80 commands. These commands will be sent directly to the HC05 module. The command 80 plus name will give the Bluetooth module a name, 80 plus UART will help you to set the baud rate of the Bluetooth module, and 80 plus polar enables us to control PIO8 and PIO9. You have to keep in mind that the baud rate is different for different boards. If it was a success, you should be able to see an OK response for each and every 80 commands you have issued. After successfully issuing the 80 commands, you can disconnect it from the PC, and that was the end of step 1. Now, our Bluetooth module is ready to upload the code we sent to it to our Arduino. In step 2, connect it as per the schematics shown here. Basically, we will be connecting the TX pin of Arduino to the RX pin of Bluetooth module and the RX pin of Arduino to the TX pin of the Bluetooth module. And to reset your Arduino every time we upload new code, we will be connecting the reset pin of Arduino to pin 32 of the Bluetooth module as shown in this schematics. If you are using this shield, all you have to do is remove the jumpers from the headers RX set and TX set and connect it to the headers RX PGM, TX PGM and reset. And the shield should look like this. After that, connect pin 32 of Bluetooth module to the pin 32 header of the PCB. Like I mentioned earlier, it will help us to reset the Arduino board when a new code is being uploaded. Now, you can power up the circuit using a battery or a power bank. I'll be connecting it to the power bank using this USB cable, but please note that there is no connection between the board and the computer. And here we are in Arduino IDE. First we will go to Tools and Ports, and here you can see there is only one port, that is COM3. Now we will go to Bluetooth settings and click on Add Bluetooth or other devices and Bluetooth, and it will scan for all nearby Bluetooth devices and it should display our Bluetooth module. Here it is, root set BT module. Click on that, enter the pin and hit connect. Okay, it's paired now. Now click on done and you can minimize this window and we'll go back to Arduino IDE. Now go to Tools, Ports, and here you can see two more ports have appeared, right? COM4 and COM5. Now select the right port and the board. As you can see here, the on time is 500 millisecond and the off time is 500 millisecond. Let's change that to on time 2 second and off time 1 second. As you can see here on the board right now, the whole cycle is 1 second. That is on time of 500 millisecond and off time of 500 millisecond. Now we can hit the upload button and it will start the compilation process. Now the upload has started. Now do note the LEDs on the board as the code is being uploaded. See? Yes, now it's done. The new code has been uploaded and the blinking frequency has changed. The on time is now 2 seconds and the off time is 1 second. That was really easy, right? That's it guys. From now on, you should be able to upload your code to your Arduino board without even using a USB data cable. Thanks a lot for watching guys. If you like this video, give us a thumbs up, and if you have any doubts, feel free to ask in the comments down this video. See you in the next video.